Hello everybody, my name is Riley Parker, and today I will be showing you Make and CMake. I will try to show you an introduction of both Make and CMake, what they are, and also a practice program that utilizes both. An example for Make and also one for CMake. So that is it. Let us begin. What is that? Well, that in question is Make and CMake. And this is a good question, so I hope to be able to explain it to you in these next couple slides. However, I have an example before this. So, an example before using Make or CMake, I give you Bob the programmer. Bob is a programmer in college. He has a huge final coding assignment that has 25 files that all relate to each other. Bob only has 3 hours until he must turn in his assignment. However, Bob does not know how to keep his files in check and sadly turns in faulty code. How could Make and CMake change this? And you can see bottom right hand corner, that is Bob, and Bob is looking very sad. So hopefully we can change that. An introduction to both Make and CMake. Make, a brief overview. Make is a build automation tool that automatically builds executable programs and libraries from source code by reading files called makefiles, pretty intuitive, which specify how to derive the target program. Besides building programs, Make can also be used to manage any program where some files must be updated automatically from others whenever the others change. Make is also implemented in both C and C++. Thus, since we're using C++, we could use it in a later program. And I'll show you an example later in this video, or part 2 of this video, to be more exact. CMake intro. CMake is a cross-platform free and open source software for build automation, testing, packaging, and installation of software by using a compiler independent method. Unlike Make, CMake is not a build system, but rather it generates another system's build files. CMake supports direct hierarchies and applications that depend on multiple libraries. It is usually used in conjunction with native build environments such as Make, Qt Creator, Ninja, Android Studio, Apple's Xcode, and Microsoft Visual Studio. I would like to clarify that these are not the only native build environments, but these are just some that I was lucky enough to find, and these are my examples of a couple that you could possibly use in school, on your own, or for a job later in life. Next. But wait, there's more. Like I briefly explained, part 2 is next, examples of CMake and Make with code. So far, we have gone through what Make and CMake is, and more in depth into how we could possibly use CMake. For example, I'll go back. Like I said, CMake can be used in conjunction with Make and all of these other native build environments. So, pretty nice. And I'll show you later in the next video an example of something you could use. It's a very simple example, just a brief intro, and that's it. However, with Make, I'll do the same, but I would also like to clarify that a Make file is really just a more complicated .txt file, so a text file. And we've seen some forms of text files. I'll briefly explain that in the next part of the video. But Just wanted to let you know. It looks like a complicated name, but it's really not that intuitive. Or it is intuitive, but it's not that hard to understand what it actually is. So, yeah, like I said, this is part one. And yeah, good luck on the next part. Hello. Like I said in the previous video, my name is Riley Parker, and this is the second part of my CMake and Make intro. Let us begin. Part 2. Examples of CMake and Make with code. Let's do it. Have we seen a Makefile? In the previous video, I explained that a Makefile was pretty much just a text file, and we've seen text files before, for example, in world, I believe it was world data, or CSV, it was a .csv file. Pretty much they go hand in hand. I'll show you, like I have in this slide, I'll show you that in the example that you could possibly use a CSV file, but a dot or make file makes these things easier. So, easy answer, like I just said, we have not necessarily seen a make file. Although the file name sounds strange, however, all it is a text file that is used or referenced by the term make. However, we have used similar files to this that are only fractions of what a make file can really do. Like I just explained, that could be a .csv file or just a regular .txt. A make file would be used if we had larger sums of text that needed to be changed with other text files, thus being way more complicated than a regular text file should have been. I had a little typo there, but should have been is what should be there. So, next slide. Have we ever used CMake? And similarly to Make, the answer is tough. CMake incorporates Make along with other building environments as stated before, but in this class, we have not used it. Some of you might have, but in this video, I'm making it to where if you're watching it, then you really haven't seen Make or CMake before. So it is, however, very possible for some of you, like I said, to have used it in the past. In the past, my bad. If you like making applications in Android Studio or other related apps that I explained in part 1, then you might have come across this used in a helpful way. And yeah, next slide. Let's get into the nitty-gritty. These are some code examples for both Make and CMake. Simple code example for Make. This, I say it's simple, a couple slides long, but hopefully you're paying attention and it should be good. So, top image, simplest makefile. Echo is a key word for the specific makefile. So far in my research, I have found that echo is really just used in this one. However, it could be used in another makefile. I just couldn't find anything for that. So, sadly, that's the case. Second image, I have top image again, but it's on top of the text, so my bad. But output of the previous statement, so the very top image, echo allows the text, quote, hello world, to be printed out for the user. And this make example I did get from makefiletutorial.com. I'll show you later in the video all of my sources, but wanted to give them credit because this is their stuff. Next slide. Simple code for make continued again. Bottom image. The following makefile has 3 separate rules as shown down below. We are implementing a program called blah in a series of steps. And this is what the picture says if you can't see it. Beginner examples. The following makefile has 3 separate rules. When you run make blah in the terminal, it will build a program called blah in a series of steps, as below. Make is given blah as the target, so first it searches for this target. Blah requires blah.o, so make searches for the blah.o target as well. Blah.o requires blah.c, so make searches for the blah.c target as well. Blah.c, however, has no dependencies, so the echo command is run. The cc-c command is then run because all of the blah.o dependencies are finished. The top cc command is run because all of the blah dependencies are finished. That's it. Blah is a compiled C program. So as you can see below, we have blah colon blah.o. cc blah.o-o blah runs third. Blah.o colon blah.c. cc-c blah.c -o blah.o runs second. Blah.c echo int main return 0 is greater than blah.c runs first. Like it said in the text above, a little complicated, but it'll make more sense if maybe we don't use blah. A little hard to understand what blah meant, but we used it here, or they used it here, my bad. Like I said earlier, all of this is from Makefile tutorial. This is all their stuff. I just wanted to show it to you to make it easier. And yeah, that is, so far, this is what we have for the code. Let's go to the next one. SCE for make continued. The bottom image. Top part of the image are called the all target. Layman's terms, simple way of combining multiple same type targets together and allows for easier use later. The bottom part, however, is about how to make multiple targets by using the money @ sign. So two signs together, we know those signs, pretty easy. That sign together, it is an automatic variable that contains the target name. Pretty nice, pretty simple to use. Just kind of helps make the code easier to run. Maybe not easier to run, but easier to understand and easier to write for the programmer. So yeah, next slide. Simple code example for CMake. So we just finished make. Hopefully you did well on those questions, but this is CMake. So let's begin. Top image. Example for a simple project requiring only 3 lines of code. Sets project name and adds an executable for later use. Bottom image. Using the project function, this sets the project name to tutorial and the version to version 1.0. So, like I just explained, on the top image we have CMake _minimum _required version 3.10. Then after that we have project parentheses tutorial close parentheses. That sets our project name, and then we add the executable with add _executable tutorial.cxx. Second image, CMake _minimum _required version 3.10, just like the previous image. And here we have project parentheses tutorial version and then 1.0. So project, I'm not exactly sure. It has either 1 or 2 requirements that it needs to fill, and they used 2 examples, one with 1 and then another with 2. So yeah, I also got all of this simple code for CMake from cmake.org, link below, and I will show you my sources under this as well. Next slide. Simple code example for CMake continued. Top image. Following the last, this is configuring a head file to pass the version number to the source code. The bottom image, however, because this configured file will be written in a binary tree. We must add that directory to the list of paths to search for included files. We will add these lines of code to do so. So, the top image, all it says is, if you can't see it, configure underscore file, and in there we have our tutorial config.h.in and tutorial config.h. Second image says target underscore include underscore directories, and then in parentheses we have tutorial public, and then in quotes we have $ project binary dir, and all that's in brackets, close quotes, and then close parentheses. Pretty interesting stuff. Let's continue. Simple code example for CMake continued again. Top image. Using your favorite editor, create quote tutorial config.h.in in the source directory with the following contents. The bottom image, after modifying tutorial.cxx to include the configured header file called tutorial config.h, this code lets us print out the executable name and version number. So like I just said, the top image, if you can't see it, we are just defining tutorial underscore version underscore major twice. And like I said previously, sadly, I'm not exactly sure why they did it twice, but I will look into it. And on the second image, we just have a simple if statement that just lets us print the version, the usage, and the number. So yeah, let us continue. Next slide. Okay, I'm pretty sure this is the second to last one. Sorry about sorry about it being so long, but here we go. CMake continued. The image. All of layman's terms, I will try to summarize it the best I can. All this code to the left is trying to do is to add some C++ features to the project. Pretty simple way of including some somewhat complex algorithm. So, here we go. Specifying the C++ standard. Let's add some C++ 11 features to our program by replacing atof with std : stod in tutorial.cxx. At the same time, remove #include cstdlib. And here we can see tutorial.cxx constant double input value is equal to std : stod rgov : or bracket 1 close bracket close parentheses and colon at the end. Remember the colon makes things easier. Next, we will need to explicitly state in the CMake code that it should use the correct flags. The easiest way to enable support for a specific C++ standard in CMake is by using the CMake _cxx standard variable. For this tutorial, set the CMake what I just said variable in the cmakelist.txt file to 11 and CMake _cxx standard required to true. Make sure to add the CMake _cxx standard declarations above the call to add _executable. And here's what they were talking about. You have the CMake minimum required, the version on the top. You have your project that you're setting, tutorial version 1.0, and then you specify the C++ standard setting CMake _cxx standard to 11, and also setting CMake _cxx standard required to true. Okay, next slide. I am 100% certain that this is the last one. So let's sum this up in a nice and easy way, and possibly you can get back to Bob. Simple code example for CMake continued. Last part. We're almost there. Image. We are now able to rebuild our program using our specified C++ standard. This will allow us to use the newly created tutorial with the same commands as before. So in the image, if you can't see it, let's build our project again. We already created a build directory and ran CMake, so we can skip to the build step. And right there they have an example of it. cd step1 underscore build and CMake dash dash build. And yeah. Now, we can try to use the newly created tutorial with the same commands as before. Here's how they do it. Tutorial 429.496.7296. They also use tutorial 10. They also use just regular old tutorial. You have to check the version number should be now reported when running the executable without any arguments. And yeah, simple explanation, or not simple explanation, but somewhat simple code for CMake. And yeah, I believe Bob is next, and let's hope Bob has learned from his past mistakes and will do better now. Back to Bob. Let's see if he can do better with his newfound skills. You got this, Bob. Bob the programmer, new and improved. Bob has now educated himself with the use of Make and CMake. Now, working on his final project for college, he successfully created and used multiple makefiles. On top of that, he was able to finish his project early and could go on summer vacation before everyone else in his class. Congrats, Bob. You did it. He ended up getting a 110 on the final because his teacher was so impressed with him using Make and CMake correctly. Bob looks a little happy now, I think, but good job. Hopefully we can do the same. And yeah, next slide. End of the presentation. Thanks for listening, and be like Bob. And I'll explain the pictures. So we have a meme that I found to the left, and we have a meme to the right. And yeah. And next slide are my sources. Here are my works cited. Used Wikipedia in the beginning. Like I said, the Makefile tutorials, I used all of them somewhat in my complete slideshow. But yeah, that was it. Thank you for watching, and I'm glad that I was able to teach you both Make and CMake. And hopefully we can use these in the future correctly, and we can get that 110 just like Bob did. Thanks for watching, and have a good day.